Lesson: Asymptotes and Rational Functions. Education must lead us from the irresponsible opinion to true responsible judgment. It must lead us from chance and arbitrariness to rational clarity and intellectual order. Therefore, let us guide our students over the road of discipline from materials through function to creative work. Ludwig Mies van der Rohe. General definitions of asymptotes. An asymptote is a line that a graph approaches but does not intersect. A graph could have vertical, horizontal, slant, or oblique asymptotes. 1. The line x equals a is a vertical asymptote if the graph increases or decreases on one or both sides of the line as x moves closer and closer to x equals a. When x approaches a from the left, y drops towards negative infinity. As x approaches a from the left, y rises towards positive infinity. As x approaches a from the right, y drops towards negative infinity. As x approaches a from the right, y rises towards positive infinity. The graph of a rational function in lowest terms has a vertical asymptote x equals a if x minus a is a factor of the denominator and x minus a is not a factor of the numerator. Example: f of x equals the quantity x minus 2 everything squared times x plus 3 times x plus 7 everything over the quantity x minus 2 times the quantity x plus 3 everything cubed times the quantity x minus 5. Reduce the fraction by the GCF, the quantity x minus 2 times the quantity x plus 3, obtaining at the numerator the quantity x minus 2 times the quantity x plus 7 divided by the quantity x plus 3 squared times the quantity x minus 5. When f is written in lowest terms, x plus 3 is a factor of the denominator and not a factor of the numerator. Thus, x equals negative 3 is the equation of one of the vertical asymptotes. When f is written in lowest terms, x minus 2 is not a factor of the denominator. Thus, there is no vertical asymptote at x equals 2. X minus 5 is a factor of the denominator and not a factor of the numerator. Thus, the other vertical asymptote is x equals 5. The line y equals b is a horizontal asymptote if the graph approaches y equals b as x increases or decreases without bound. When x approaches negative infinity, y approaches b. The graph of a function with two horizontal asymptotes. Here we have y equals 2 and y equals 4. As x decreases without bounds, y approaches the line y equals 2. When x approaches infinity, y approaches c. As x increases without bound, y approaches the horizontal line y equals 4. Facts about a horizontal asymptote of a rational function. If the degree of the numerator is less than the degree of the denominator, then y equals 0 is the equation of the horizontal asymptote. Example: f of x equals 3 divided by x plus 5. The degree of the numerator is equal to 0. The degree of the denominator is equal to 1. Y equals 0 is the equation of the horizontal asymptote. Indeed, if x approaches positive and negative infinity, y approaches 3 over positive and negative infinity. Thus, y approaches 0. Thus, y equals 0 is a horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then the equation of the horizontal asymptote is y equals the ratio of the leading coefficients of the standard form of both numerator and denominator. Example: f of x equals 4x minus 1 divided by 3 minus 2x. The degree of the numerator is 1. The degree of the denominator is 1. And the leading coefficients of the standard form are 4 and negative 2. The equation of the horizontal asymptote is y equals 4 divided by negative 2, or y equals negative 2. Indeed, f of x equals x times the quantity 4 minus 1 over x, everything over x times the quantity 3 over x minus 2, which equals 4 minus 1 over x, everything over 3 over x minus 2. When x approaches positive negative infinity, thus y approaches 4 minus 1 over positive negative infinity, everything over 3 over positive negative infinity minus 2, which equals 4 plus minus 0, everything over plus minus 0 minus 2, which equals 4 over negative 2, which equals negative 2. Thus, y equals negative 2 is the equation of the horizontal asymptote. If the degree of the numerator is greater than the degree of the denominator, then the graph has no horizontal asymptote. Example: f of x equals 3x squared, everything over x plus 2. The degree of the numerator equals 2. The degree of the denominator equals 1. The graph of the function f has no horizontal asymptote. Indeed, f of x equals 3x squared, everything over x times the quantity 1 plus 2 over x, which equals 3x, everything over 1 plus 2 over x. When x approaches positive negative infinity, thus y approaches positive negative infinity over 1 plus minus 0, which equals positive negative infinity. Thus, the function has no horizontal asymptote. The line y equals mx plus b is a slant asymptote if the graph approaches y equals mx plus b as x increases or decreases without bound. X approaches negative infinity, y approaches mx plus b. X approaches infinity, y approaches cx plus d. An example of a function that has a slant asymptote. As x approaches positive negative infinity, y approaches 0.5x plus 0.5. The slant asymptote is y equals 1/2 x plus 1/2, illustrated by this red dashed line. Facts about the slant asymptote of a rational function. If the degree of the numerator is 1 greater than the degree of the denominator, then y equals the quotient of the numerator and the denominator is the equation of the slant asymptote. Example: f of x equals 3x squared over x plus 2. Doing synthetic division, the coefficients of the numerator are 3, 0, and 0. The root of the denominator is negative 2. Bring down 3. multiply across, and then add diagonally. Multiply across, 3 times negative 2, add the 0 diagonally, which equals negative 6. Then we multiply across and add diagonally again. So we have negative 2 times negative 6, and add the 0 diagonally, which evaluates to 12, which is the remainder, and the quotient is 3x minus 6. The equation of the slant asymptote is y equals 3x minus 6. Indeed, according to the division remainder theorem, f of x equals 3x minus 6 plus 12 over x plus 2. As x approaches positive negative infinity, the fraction approaches 0. Thus, y approaches 3x minus 6. The vertical distance between the graph of f and the line y equals 3x minus 6 approaches 0 as x approaches positive negative infinity. General definition of a hole. A hole on a graph of a rational function looks like a hollow circle. It represents the fact that the function approaches the point but is not actually defined on that precise x value. A hole occurs at a 0 of the denominator that is also a 0 of the numerator with the same multiplicity. Example, f of x equals the quantity x minus 3 times the quantity x plus 1, everything over x minus 3. F is not defined at x equals 3. We can reduce the fraction by the GCF, x minus 3. There is a removable discontinuity that is represented as a hollow circle on the graph. F is not defined at x equals 3. The hole is at point of coordinates 3, 4. Important. Whereas vertical asymptotes are sacred ground, horizontal and slant or oblique asymptotes are just useful suggestions. Important. Whereas vertical asymptotes indicate very specific behavior, horizontal and slant asymptotes indicate general behavior. Whereas the graph of a function can never touch a vertical asymptote, the graph can touch or cross a horizontal or slant asymptote at points in between negative infinity and positive infinity, not towards negative infinity and positive infinity. Example, the graph crosses the horizontal asymptote y equals 0 at 2 points. Point of coordinates negative 3, 0 and point of coordinates 2, 0. The graph does not cross the horizontal asymptote towards negative infinity and positive infinity. Another example, the graph crosses the slant asymptote at origin. The graph does not cross the slant asymptote towards negative infinity or positive infinity, as you see here. Question 1. True or false? The line x equals 5 is a vertical asymptote of the function f. F of x equals, at the numerator, x cubed minus 15x squared plus 75x minus 125, everything over the quantity x squared minus 2x minus 15 times the quantity x minus 4. To decide whether x equals 5 is a vertical asymptote, we must factor completely both the numerator and the denominator over the set of real numbers. The numerator compresses into a binomial cubed. The quantity x minus 5, everything cubed. Using the guess and check method, we can factor the trinomial in the denominator. Sum equals -2. Product equals -15. Two numbers that multiply to -15 and add up to -2 are -5 and +3. Thus, the prime factorization of the trinomial is the quantity x minus 5 times the quantity x plus 3. At the denominator, we have the quantity x minus 5 times the quantity x plus 3, finally times the quantity x minus 4. We can reduce the fraction by the GCF, x minus 5, obtaining at the numerator the quantity x minus 5 everything squared over x plus 3 times x minus 4. When x approaches 5, y approaches 0 over 8 times 1, which means y approaches 0. The point of coordinates 5, 0 is a hole on the graph of f. The graph does not have a vertical asymptote at x equals 5. Thus, the statement is false. Question 2. Always, sometimes, or never. If -2 is a root of the denominator, then x equals -2 is a vertical asymptote of the function f. Example number 1. f of x equals 3 over x plus 2. -2 is a root of the denominator, and it is not a root of the numerator. Thus, x equals -2 is a vertical asymptote of the function f. When x approaches -2 from the left, y approaches 3 over 0 negative, which means y approaches -infinity. When x approaches -2 from the right, y approaches 3 over 0 positive, which means y approaches infinity. Therefore, indeed x equals -2 is a vertical asymptote of the function f. Example number 2. f of x equals 3 times the quantity x plus 2, everything over x plus 2. -2 is a root of both numerator and denominator. We can reduce the fraction by the GCF, x plus 2, which equals 3. The graph does not have a vertical asymptote at x equals -2. There is a hole at x equals -2. We found an example that shows the statement is true and another example for which the statement is false. Thus, the statement is sometimes true. Which of the following statements is true? 1. All rational functions have a horizontal or slant asymptote. Let f of x equal x over x. F is a rational function. F is undefined at x equals 0. And f of x equals 1 for all x belongs to the set of real numbers minus the set made up of 0. The graph of the function f has no asymptote. The graph has a hole at x equals 0. Thus, statement 1 is a false statement. Statement 2. The line y equals 4 is a horizontal asymptote of the function f, where f of x equals 4x plus 1, everything over x minus 5, everything plus 1. Bring to the same denominator. Equals 4x plus 1 plus x minus 5, everything over x minus 5, which equals 5x minus 4 over x minus 5. Both the numerator and denominator have a degree of 1. The leading coefficients are 5 and 1. The line y equals 5 is the horizontal asymptote of the function f. Thus, statement 2 is a false statement. Statement 3. A rational function can have both a horizontal and a slant asymptote. A function must pass the vertical line test. Thus, the graph of the function cannot approach two different lines. Statement 3 is also false. All three statements are false. Thus, the correct answer is E, none. The end.